Good day to you, grade 12 learners. Welcome to today's physical sciences lesson. My name is Ndabezinhle Dliwayo. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. I hope I find you well. Right, in our lesson today, we want to look at vertical projectile motion, which is part of our mechanics section, which carries about 13 plus or minus 13 marks in your examination. Typically in your paper 1, you can see the marks there from our past examination questions. So we're saying at the end of the lesson, you should be able to attempt typical examination questions that is on the vertical projectile motion. So we're going to do a number of questions together, grade 12s. So ensure that you have your pen, your paper, and your calculator, and we do this work together. Right, so for our pre-knowledge, it's all your knowledge on the vertical projectile motion represented in words, diagrams, equations, and graphs. So now, what can we think of when we talk of vertical projectile motion? You think of the term free fall. So are you in a position to define the term free fall? Are you able to interpret diagrams of your vertical projectile motion? Are you able to pick the necessary detail that you need to tackle your examination questions? And importantly, it's the equations. Yes, equations, grade 12. Which equations are we talking about? The 4 equations. 1, we know that the final velocity is equal to our initial velocity plus acceleration multiplied by time. This is one of the equations that we need to remember when we are dealing with these questions. And then what else? Number 2, final velocity squared is equal to what? Is equal to your initial velocity squared plus 2a delta y. Okay, so this is another one of the equations that you need to recall, grade 12s. Number 3, which other equation do you remember? We're saying delta x is equal to initial velocity times time plus half a delta t squared. Right, so you need to remember all these equations of motion, and we're saying you should be able to apply them. Identify the variables that you have from your given formula, and then you do the necessary calculations when it comes to your equations of motion. Right, now again we speak of the graphs of our equations of motion. Are you able to plot graphs of equations of motion? Remember your velocity. They say velocity in meters per second, and this side delta t. You know that your velocity can be positive, your velocity can be negative, grade 12s. When you're dealing with questions, you need to assign a reference positive direction. Okay, anything besides that, you know that if the motion is in the opposite direction to a reference positive direction, then it makes your velocity negative. Okay, now let's look at the man there who's throwing the ball upwards then. Okay, if you are asked to plot that graph, typically you should remember the first thing that you need to do is to assign your reference positive direction. Let us say the upwards is positive. Okay, let's say our upwards is positive. Right, so it means as the object is going upwards, the velocity is positive. As long as it is going upwards, the velocity is positive. But take note, as our object is rising, grade 12s, what is happening to the velocity? It is decreasing, right? until when it reaches its maximum height, it stops instantaneously, meaning the velocity becomes zero. Right. So as our object is rising, our object is decelerating, the velocity is decreasing. So what do we know when deceleration occurs? We know that when deceleration actually occurs, it means the sign of our velocity is opposite to the sign of our acceleration. So if upwards is positive, then it makes our acceleration due to gravity negative. And how is your graph going to look like? Okay, upwards is positive. So we'll start somewhere there at a certain point where we're saying the velocity of your object is positive, but we know that it decreases at a constant rate. Okay, as it decreases at a constant rate, when it reaches its maximum height there, we're saying the velocity becomes zero. Okay, and what do you know about that time delta t? You know that is your time to reach your maximum height when it stops instantaneously there. Okay, and then we follow. When it falls back, it is now changing direction. And what does it mean? It means our velocity now tends to be negative. It increases in the negative direction. And we're saying when it reaches the ground there, that is going to be your final velocity, VF. Your final velocity is going to be there, and that is going to be your initial velocity. And you're saying you're coming up with this graph as a result of what? As a result of assigning your reference positive direction grade 12. Right, so this is just a reminder for you to know that these are the kind of things that you need to apply when you're dealing with your questions. Okay, and right, let us erase this a bit for now. Right, another situation, your object can be projected from a certain height. Let's say your object is projected from a cliff, and then it goes up, reaches the maximum height, then it gets to the ground. Right, you need to remember how then do you apply your equations of motion. Okay, we're still saying there is your maximum height. Okay, and at your maximum height you are saying the velocity of your object is now zero. All right, and then your object is going to drop, and let's say that height is actually let's say x meters. In applying your equations of motion, if you assume your reference positive direction to be upwards, it means now when you get the displacement of your object, the final displacement of your object, it is going to be a negative x. Don't forget that. Your final displacement is going to be negative. You are going to pass that point, which is zero, and you go down, giving you a final displacement of a negative x, which we use now to substitute when we're dealing with our calculations. Your final velocity will be there, VF, at a certain point. Okay, right, so we're going to do so many questions now so that we can see how we can apply all these equations of motion. I hope you are actually ready. Let's start with our first question, and as you can see, on average it's about 2, 5, 10, 13 marks. So as we go over this exercise, just tick for yourself and see how much you're going to score. All these questions are taken from your past examination questions. Right, so for the first one, for this first part, I'm going to give you 5 minutes starting from now. 5 minutes. Right, welcome back. Let us go over the question together, grade 12. Now, a ball of mass 0.5 kilograms is thrown vertically upwards from the top edge of a building which is 15.3 meters high. Right, the ball reaches a maximum height of 5.89 meters. I hope you can see that from the diagram there. The ball strikes the ground and bounces vertically upwards. reaching a maximum height at point P, okay, as shown in the diagram there. Ignore the effects of air friction. Now, the first part, define the term free fall. Okay, now when it comes to definitions, consult your examination guideline. Follow the definitions as they are, as prescribed by your examination guideline. So master all the definitions that you need to know on this section on the vertical projectile motion altogether. So we're saying free fall is motion under the influence of the gravitational force only. So the only force that is actually acting is the gravitational force. And then you get your two marks. I hope and believe that we all got that correct. Right. Let us proceed. Using only equations of motion. Using only equations of motion. Calculate the speed at which the ball was projected upwards. Right. Calculate the speed at which the ball was projected upwards. So in other words, what do we want? We need the initial velocity. We shall call it VI, the initial velocity of the ball. Okay. And how can we get that? Looking at the data that were given from the question, we know that when the ball reaches its maximum height there, we will have a final velocity there. And what will be the final velocity is going to be 0 meters per second, because it is going to stop there instantaneously, right? And what else do you have from the information that you have there on the on this question? That is your displacement, which we'll call delta y, okay, to reach to the maximum height. Are you following, grade 12s? Okay, and then what else do we know? Remember, we said when you're dealing with these questions, assign a reference positive direction, and in this case we're going to take our upward direction as positive. And since the object on going upwards, you can see that it is decelerating, the velocity is actually decreasing until it reaches 0. What does it tell us about g? Our g is going to be negative 9.8 meters per square second. So this is the data that you have. And now looking at this data, you go back to your question and say, what do I need to calculate? You need to calculate the speed at which the ball was projected upwards, your VI. You have VF, you have G, and you have Y. And then you go to your equations of motion, the 4 equations of motion. And then you say, which equation can I apply? The one that will have only one unknown variable. And you're going to realize that you can use the final velocity squared is equal to initial velocity squared plus acceleration plus 2 multiplied by your acceleration delta y. You can check. We have our delta y, we know it. We have our acceleration due to gravity, we know it. Okay, and we have our final velocity, we know it. And it makes the initial velocity, the one that we want to calculate, the only unknown variable. Are you seeing the trick, grade 12? Right, then we substitute now. Okay, final velocity, we say it is 0 when it stops instantaneously. Our g is a negative 9.8, and then our displacement there is a positive 5.89 meters. And I hope we got it correct. And then what are we getting? We're getting a value of 10.74 meters per second upwards. Remember, here we are just calculating the speed, so we do not care about the direction. It is not needed. Our speed, we know, is just the magnitude of our velocity. So we get a speed of 10.74 meters per second, and I'm sure we all got it correct. Now take note, keep this value, we write it somewhere. Normally our questions are structured in a manner that the first part you are going to realize you may need the information to do further calculations. Right, so you have your formula, substitution, and your solution, and you get your 3 marks. Okay, let us proceed to the next part. Right, now 1.31, after the collision with the ground, the ball leaves the ground with a speed of 11.92 meters per second. Now calculate the amount of kinetic energy lost by the ball during the collision with the ground. So in other words, we need to calculate our change in kinetic energy. And our change in kinetic energy, delta EK, is equal to the final kinetic energy, that is EKF, minus the initial kinetic energy, Ki. And then we're saying our kinetic energy is half mv squared. So for us to solve this, to get the energy that is lost, we need the final velocity, right? We also need the initial velocity. So how do we identify these two? Follow the motion of the ball, okay, up to the collision. So please, can you pay attention and listen to this part? Remember, in our first part, in the previous part, we calculated the velocity with which the ball was projected upwards, right? Then the ball went to the collision. When it hit the ground, it now had assumed a new velocity, which we did not know. And this is the velocity that we need in our formula. When it hits the ground, the final velocity with which it hits the ground, we now take it as the initial velocity for the collision. Are you getting the sense? The final velocity of its motion becomes the initial velocity of the collision, because this is the velocity with which it comes with contact with the ground. Okay, then it rises with a new velocity now, this one, with a speed of 11,92 meters per second. So 11,92 meters per second becomes our final velocity after the collision. Is it making sense, grade 12? Right. So the first step that we need to do now is we need to calculate this velocity with which it comes into contact with the ground. Okay, and for us to do that, we need to identify a suitable formula. And how do we identify our suitable equation? We first of all identify the data that we have in our question. Okay, so we are projecting it from there with a velocity that we know, that we calculated from the previous. So this case we have VI from our previous question. Let's check the value. You see the speed with which it was projected upwards, 10,74 meters per second. Do you see that one? So our VI is going to be 10,74 meters per second. Are we following? And then it is going to move upwards and then downwards until it reaches that point where we're going to have VF, which we do not know. In this case, this is our final velocity, which we're going to use as an initial velocity to get the energy that is lost. Okay, what else are we getting from the question? Right, we said upward direction is positive, therefore it makes our G negative. Our acceleration due to gravity is going to be 9,8 meters per square second. Right, what else do we have from the question? Let's follow the motion. It went up and then down. Okay, so this is its original position, which is at 0. When it goes past it, it means now our delta y is going to be what? A negative 15,3 meters. Don't forget that. So we have delta y, we have G, we have VF, and then we have VI. So what can we calculate now? We can get this final velocity using our formula. Final velocity squared is equal to VI squared plus 2a delta y. And then we can substitute those values. Our initial velocity, 10,74. Okay. Our G, a negative 9,8. And then our delta y, a negative 15,3. Okay. Let's follow these calculations, grade 12. Okay. Right. Then we can do the math there and we get a negative 20,38. Remember why it is negative there? Because we said our upward direction is positive. So it is going to hit the ground with a velocity of a negative 20,38 meters per second. So now, remember now we're saying we have found the velocity with which it hits the ground. Now we are concentrating on the collision. We're progressing with our calculation. So it came with a negative 20.38 and then it left with 11.92, a positive 11.92 going upwards. So 11.92 now becomes our final velocity of the collision. All right, so now we can substitute in our formula to get our change in kinetic energy, or the kinetic energy that is lost, bearing in mind that kinetic energy is equal to half mv squared. So final kinetic energy, half mass times the final velocity squared, and the final velocity in this case we said 11.92. okay, initial kinetic energy, half mvi squared, mass times the initial velocity squared, and we're saying this value that we got becomes our initial velocity of the collision. So we can calculate our energy lost, half m final velocity squared minus initial velocity squared. Let us substitute the values. You can see this is our final velocity as we discussed, and this is our initial velocity of the collision, right? And there is the mass of our ball. And then what value are we getting? We're getting a value of negative 68.31 joules. Okay, right, I hope that makes sense. Okay, let us proceed. Now we want to calculate the time taken for the ball to reach point P, okay, from after leaving the ground. Okay, how do we calculate the time taken? Again, let's take note of the values that we have. We have a velocity with which it left the ground. That one. Do you see that one? 11.92. So in this case, going up with 11.92, that becomes our VI. And it's going to be a positive 11.92 meters per second. This is the speed with which it leaves the ground. What else do you know? You know of your G. Our G is a negative 9.8 meters per square second. Okay, and it's going up to point P there. All right, so we need to calculate the time taken for the ball to reach the point after it leaves the ground. So we're saying our upwards is positive. We have our A, okay, and we also have our final velocity. At point P, our final velocity is 0 meters per second. Remember, this is the maximum height that it reaches after bouncing, and therefore it comes momentarily to rest, grade 12s, and therefore the velocity will be 0 meters per second. So you have initial velocity, you have G, you have VF, and you want to calculate delta T. So you have listed this data from your question, and then you choose the simplest formula to make your life easy to calculate your delta T. So now we can substitute those values there into our formula, okay, and then we get our delta T as 1.22 seconds. So the time it will take to reach point P is 1.22 seconds. The formula, substitution, your value there, you get your 3 marks. Right, I hope these are quite interesting questions. Right, for you to really master these questions, you need to practice and practice. Okay, that is the only way you can learn how to quickly identify the equation to use in a particular situation. But as I said, list the data that you have from your question. Okay, having listed the data, you can identify the equation that you can use with only one unknown variable, so that you can solve whatever problem you are given. Right, now we said we should also be able to interpret graphs. Okay, let us look at this question on the graph there. Now for this question, I'm going to give you 3 minutes. Right. I hope we are done with this question. So let us look at it together. Pay particular attention on how we actually analyze these velocity time graphs. Now, the velocity time graph for the motion of the ball from the instant it is projected upwards from the top edge of the building until the time it reaches point P is shown. Write down the numerical values indicated by each of the following. We were looking at the letter K. So can you follow K there? You can see K there. Right. For us to be able to understand what the value of K is, let us follow the graph first. Point L. You can see point L there. What is the velocity of point L? We start there. Right. The object is projected upwards. It reaches the maximum point and then it drops to the ground. Right. So at this point, take note of this point. This is our point L. In point L, we have an initial velocity VI of our ball. It goes up. And you can see as the object progresses going up, the velocity decreases until it reaches 0. And this is at the point where we are at the maximum height. Are you following? Velocity is decreasing at a constant rate of negative 9.8 meters per square second. Right. And then when it drops now, it is changing direction. Therefore, your velocity starts to be negative. And then what is this point? This is the point where it bounces back. And we said it is going to bounce back. The question told us it bounces back with an initial velocity. What was the initial velocity there? It was 11.92. It is the speed with which it left the ground after bouncing. Okay, so K is the velocity or the speed after hitting the ground, and we had a value of 11.92 meters. And hence take note, it is positive because it was going upwards, right? But as it starts to go upwards again, what happens? The velocity starts to decrease until it reached its maximum height at point P. That is the whole story of our graph. Okay, grade 12. So what does it mean? What is our L? Our L, remember, this is the speed with which our ball was projected upwards, and we're saying we got a value of 10.74 meters. The speed with which our ball was projected. Okay, and then we get to T2 minus T1, this part. T2 minus T1. T2 minus T1. Right. So take note, at this point, the ball bounces and its velocity goes up to 11.92. This is the speed with which it leaves the ground, right? And then there, the velocity is now 0. This is at its maximum height at point P. So what is T2 minus T1? This is the time it took for the ball to reach point P, and we calculated that time to be 1.22 seconds. The time of the bounce, from the bounce to the maximum height of P, and we got a value of 1.22 seconds. Right. I hope you were also able to get that correct. Right. Now let's proceed to question 2. You're going to realize question 2 is also similar to what we're doing in question 1, and hopefully you'll do much better than what you may have done in question 1. So now let us go ahead again and practice and practice and practice. Right. So question 2, I'm going to give you another 5 minutes. Right, welcome back. Now let's look at our question 2. We're saying a ball is thrown vertically upwards from the top of a building of height 25 meters. You can see there. On its way down, the ball passes a door which has a height of 1.9 meters, right? And then strikes the ground as shown in the diagram below. Okay, quite an interesting question. Ignore the effects of air friction define the term free fall, right? I believe this one we met. So by now you should be knowing free fall is motion in which the only force acting is gravity, weight, or your gravitational force. Okay, so that one I believe we now know. Right, now we need to look at the second part now. Calculate the time taken for the ball to reach its maximum height. Okay, remember we are here. The ball is projected there with an initial velocity of 12 meters per second. That was our VI, the velocity with which it left the ground, 12 meters per second. When it reaches its maximum height, it stops instantaneously, making a final velocity of 0 meters per second. Okay, and then what do we know about G? If we're saying upward is positive, our acceleration due to gravity is going to be a negative 8 meters per square second. Right, you need to calculate delta T, right? And you're saying you have initial, you have final, and then you have G. So your simplest formula is going to be final velocity is equal to initial velocity plus acceleration times time. Okay, so you substitute there, right? So formula, substitution, and your value for your delta T, you get 1,22 seconds. That will be the time it takes the ball to reach the maximum height. Okay, and let us proceed to the next part. The velocity with which the ball strikes the ground. You can see it is similar to question 1, and I hope this time you really found it easy to do the calculation. Right, so where do we start? You identify the data that you have so that you can identify the appropriate formula or equation. So this is our initial velocity VI with which it is projected. Okay, and then what else do you have? You have our G, which we say it is a negative 9,8 meters per square second. Okay, and then what else do you have? Remember, you want to get the velocity with which the ball strikes the ground, and we shall call it our final velocity VF. We don't know it. Okay, what more information do we have? Remember, this is your reference point where you started. Just give it a 0. Upward is positive, so when you go past it in the opposite direction, it makes your displacement now negative, meaning your delta Y in this case is going to be a negative 25 meters grade 12. Master that. When you're projecting from a certain height, the moment your ball passes that point and goes beyond it, we're saying you're getting a negative displacement there. So your delta Y is going to be a negative 25 meters, and therefore you have VI, you have G, you have your delta Y, and then you look at your formula. You need to get VF, which is the most suitable. Look at all those 4 formulas, grade 12. Which one will be the most suitable? Which will make your VF the only unknown variable? You agree with me? We're saying our formula is final velocity squared is equal to initial squared plus 2a delta Y. Okay, we know our delta Y, we know our acceleration due to gravity, okay, and we also know our initial velocity of projection. You substitute. Okay, so you see now you're substituting. Initial is 12, negative 9,8 for your G, and then negative 25 for your delta Y. Okay, and then we get a value of negative 25,818 meters per second, which we know now is 25,18 meters per second downwards. Right, so that will be the final velocity of the object. So formula, substitution, and then the answer there and the direction. Okay, right, I hope you actually got that question correct. Right, now we need to calculate the time it took the ball to move from the top of the door to the ground. Quite an interesting question there. Right, I want you to take note. Your questions when it comes to a vertical projectile motion, there's questions like of this nature which you need to do in parts. you need to understand a certain part first so that you can progress to your solution. What am I talking about? I'm talking about this. When we look at this movement of our ball, we can split it now into two phases. Okay, the first phase is the movement of the ball from time of projection and then to there when it hits the height of the ball. Are you following, grade 12s? Right. So, and then we've got the time it passes the height of the door until it reaches the ground. So, in other words, what am I saying? I'm saying that for us to get the time it took the ball to move from the top of the door to hit the ground, we need to know at what speed it was traveling when it reached the top of the door. G we know, okay, and then the final velocity we also know because we did calculate the final velocity with which it reached the ground. So take note, the final velocity with which it reached the ground, let me take you back. We got a final velocity of a negative 25,18. Remember that? Okay, so this is the velocity with which it reached the ground. But we do not know the velocity with which it was moving at that point. Why do I need that velocity? I need it for us to be able to calculate the time. How will we calculate the time by that? Let's say the final velocity with which it reached the ground, the one we calculated, we'll call it our VF, right? Which we know. And then this velocity which we do not know at the moment, we will make it our VI. Are you following, grade 12? Right? And then we have our G, which is a negative 9,8 meters per square second. Right? So we have these 1, 2, and 3. And we're saying we need to get delta T. What will be the simplest formula to apply? Final velocity is equal to initial velocity plus acceleration delta T. Right? So the final velocity, that one, we know. Okay? The initial velocity, this one, we don't know. Are you following? Right? The acceleration, we know. The delta T, we don't know, which is what we want to calculate. Right? So I hope you understand that first part. Okay, so we need now to calculate the velocity with which our ball is going to be moving with when it reaches the height of the door. Okay, the velocity with which it is going to be moving when it reaches the height of the door. So now that's what I was talking about, the two parts. So let's start with the first part so that we get the velocity with which it will be moving at that point. So now it means we'll be looking at our motion on a different part. So follow. Now this will become our initial velocity. Please follow the grade 12. The velocity with which the ball is projected. When it reaches the top of the door, we will make that our final velocity, which we will need to calculate. Are you following? Right. What else do we have? We have G, grade 12, negative 9,8 meters per square second. What else do we have? The displacement. Remember your displacement. We said you're going to look at that point is your reference point. So it is a 0. The moment you go past your reference point, going upwards, we say it is positive. Going down is negative. So the question is, what is the value of delta y? That displacement. Yes, we know it's negative. Okay. But what value? You're going to say 25 minus 1,9. And we know it has to be a negative. Okay. 25 minus 1,9. That is your displacement. So now for us to get the velocity at that point, we have the displacement, we have the initial velocity, and we have G. And then go over those four list of equations. Which one is the most suitable for us to get our final velocity? Yes, this is the most suitable. Why? We do not know the final. We have the initial, we have G, and we have the displacement. So we can substitute those values. Our initial velocity is 12 meters per second, okay, grade 12, and then we're saying our g is a negative 9.8 meters per square second, and then 25 minus 1.9 there, it is giving us a 23.1. But remember, we said this is negative displacement because we are in the opposite direction to our reference positive direction. Okay, so this gives us a final velocity of 24.43 meters. Remember, this is the velocity at the top of the door. Okay, it's getting more interesting. Right, so now that we understand the first part, this is the second part now. You split your question into separate categories. Now, we know the velocity with which it passes, it reaches the top of the door. Now, this velocity that we now know, we will make it our initial velocity, grade 12. Are you following? We are going to make it what? Our initial velocity. Right, so this is going to be your VI. It's a negative, we got to what? 24.43 meters per second. Right, and then when it hits the ground, we have a final velocity VF, which we calculated in the previous question. Okay, we're going to look at it in a few minutes now, in a few seconds, right? And then what else do we have? We have G, which is a negative 9.8 meters per square second, and we're saying we need to calculate delta T. Are you following? I hope you're following. So looking at these variables, the simplest equation for us to use is final velocity is equal to initial velocity plus acceleration multiplied by time. Okay, and we can now substitute to get our delta t. Our final velocity, remember we said, is negative 25.18, the one we calculated from the point of projection until it reached that point on the ground. All right, and then as we said, the velocity with which it reaches the top of the door, it becomes our VI, our initial velocity. There, we put it there, okay, grade 12. And then, what else do we have there? We're saying our G there is a negative 9.8. And therefore, we can do the math there, and we get a time of 0.08 seconds. Quite interesting calculation there. So for you to be conversant in handling these calculations, you need to practice, and practice. That is why, as we are doing this lesson, I hope you are writing somewhere. I hope you are doing the calculations yourself, and you're listening carefully and following the steps. Right, the last part of our question is about velocity versus time graphs. Remember, we said you should be able to actually interpret these graphs. You should be able to draw the graphs of the motion of our projectile. Right. So for this last part, I'm going to give you 3 minutes. Right, welcome back, grade 12s. I hope you are done with the question. Let us look at it together. You can check your neighbor's graph, compare it to yours, and see who might be right, who might be wrong, and we can correct each other. Now draw a velocity versus time graph for the motion of the ball from the moment the ball is thrown upwards until it strikes the ground. Use the ground as a zero reference. Now clearly indicate the following on your graph. Okay, the velocity with which the ball was thrown upwards, we have that value. Okay, it needs to be indicated on the graph. The time taken by the ball to reach its maximum height, and we calculated that time as well. The velocity with which the ball strikes the ground. Okay, so what do you need to remember? Okay, 1. Your velocity is a vector. So this is your velocity in meters per second. This is your delta t, your time, okay, in seconds, right? So there is a positive side, there is a negative side. Our reference positive direction, we say it is upwards. So your starting velocity is going to start there, positive 12 meters per second. That is positive 12 meters per second. As the ball is projected upwards, what did we say? The velocity decreases until it reaches 0, there, at the maximum height. I follow you. And then we're saying the time taken for the ball to reach its maximum height, that is the time. You label it there. Okay, so first you're supposed to label the velocity with which the ball was thrown upwards, which is that one. Okay, now when the ball drops going down now, remember the velocity starts to increase, however in the negative direction, because when it passes, when it moves from there going down, it is now changing direction, grade 12s. Okay, it changes direction and the velocity is going to increase in the negative direction until it hits the ground at a certain time, which we can call t there, right? This is where it's going to hit the ground, still with the negative velocity. And we're saying the value there that you have of your velocity, whatever value that you have of your v there on hitting the ground, that is the final velocity, that is the velocity with which the ball actually hits the ground. So let us look at a typical solution. Your solution was supposed to look something like this. So this is the initial velocity of projection. This is the time taken to reach the maximum height, and we're saying this is the velocity with which the ball actually hits the ground. And that is how your graph is going to look like. And we're saying your graph there, remember, it is determined by your reference positive direction. In other words, how was your graph likely to look like? Let us say if upward was negative, it means your reference positive direction, we're saying upward is negative, your reference positive direction will be downward. So it means your graph was going to be in the opposite way. Take note, grade 12s. Master this, master this. So this is positive, this is negative. Okay, so if we say upward is negative, it means that 12 has to be negative. Your negative 12 will be there. Okay, and that is where your graph is going to start. Going where? Going up. And it is going up, though we know that the velocity is decreasing because it is going to reach 0 there. Okay, at the maximum height. And that will be at a time of 1,22 seconds. Right, reaches maximum height in the negative direction there, and then when it falls now, it is now changing direction, grade 12, and therefore the velocity will start to be positive. Going now down, it will start to be positive until it reaches the ground, and there, when it reaches the ground, that is going to be your velocity of a positive 25,18 when it reaches the ground. So do you see how your graph can look like depending on your reference positive direction? Okay, that being said, this brings us to the conclusion of our revision lesson for today. However, I'm going to leave you as usual with a piece of homework. I'll give you 1 minute for you to take down the question. 1 minute. Right, welcome back, grade 12s. It's been a pleasure having you in this lesson. Remember, I'd like to encourage you to consult with your examination guideline so that you may realize what exactly is expected of you when it comes to different sections of your examinations. Right, the second part of your homework, again, another minute for you to take down these questions. right, welcome back, grade 12s. This marks the conclusion of our lesson for today. I hope you found the lesson quite informative. Till we meet again, may God bless you.